Hello everyone. Today we will learn about the binary numbers. Uh, like if suppose you have a number like 5, 1, 2, then okay. So suppose you have a number 5, 1, 2, and here this you can see like in binary in decimal number system every digit like here every digit is between 0 and 9. No digit can be smaller than 0 and greater than 9, right? So that is in the decimal number system. Similarly, in binary number system, every digit will be either 0 or 1. That is, no any digit of a binary number will be greater than 1. So now I will tell you how to convert a binary any number to a binary number. Like suppose you have a number 45 and we want to convert it in a binary number. So what you have to do, you have to just divide it by 2. So if you will divide it by 2, first you have to concentrate on the remainder. Just you have to see whether number is even or odd. Like here, 45 is odd number, right? So simply you can write 1 here. And when you will divide 45 by 2, what we will get? We will get 22, right? Because we have already considered the remainder. So now we have 22. Now again divide this by 2. So if you will divide this by 2, what will be the remainder? Remainder will be 0 and we will get 21. Again 12. Now again check what is the remainder. Remainder is again 1 and here this is 5. Again what is the remainder? Remainder is again 1. Okay. Again divide it by sorry it is 2 and now divide if you will divide 2 by 2 what will be the remainder? Remainder will be 0. Okay, so it is 1. So 1 divided by 2, we will get 0 here, but the remainder will be 1. Okay, so always remember that whenever suppose you are dividing 4 by 7, and if I will ask you, or we can say what will be the remainder when this we will perform this operation. You can simply write 4. Okay, so if the divisor, if this number that we are going to divide, if it is lesser than the this one, then you can simply that will be the your remainder. That's simple method. Okay, and I can show you that also. uh, like if you want to check it, you can simply check like this: pr print 4 modulo 7. So what this will be, let's delete it first. What happened? Okay, run it. Oh, I think some other program is running, so that's why. Okay, so you can see now 4 is there, right? So what if you will use, even if you will 6, then you can see that you will get 6. So from 1 to 6, you will get the same number. Okay. Yeah. So now this is all about the binary number, and I hope you know about binary numbers now. Let's check whether the conversion that we have done is correct or not. So I am going to use the calculator and just I am going to use the binary number and I am going to paste it. You see, decimal number is 45. Okay, so that was all about the binary numbers. We can also, there's a one more method that we can use to calculate the binary numbers, like the same example that we have taken. If suppose you have to convert 45 to binary number, then just check whether this number is even or odd, because 45 is odd, right? So simply you can just write 1 here and divide it. So if you will divide this by 2, what you will get? You will get 22.5. But you don't have to consider the fractional part. You can just use the decimal number only. Again, because 22 is even number, so you can write here 0. Again, divide it by 2. So if you divide it by 2, you will get 11, right? So 11 is a odd number, so you can write here 1. Okay, now if you will divide it, you will get 5. Again, 5 is a odd number, so you overwrite 1 here. Now if you will divide, you will get 2. 2 is even number, so you write here 0, and you will get 1. So simply write here 1. So this is the method to convert the binary number. Now I will tell you about the operators that we can use on the binary numbers. Okay, so mainly there are three of this operator is there, this operator is there, this operator is there, and this operator is there, and this operator is there. So we will learn about them. What is this one? This is called left shift. This is called right shift. This is called and. This is called or, and this is called jar. Okay. So now if you are doing the left shift or divide by 2, divide by 2, both are same. And if you are doing okay, sorry, I think I made one mistake here. uh, this is right shift and this is left shift. Okay, so this is multiply by 2, multiply by 2, this is divide by 2. Okay, and this is AND operation, this is binary operation. Left shift and right shift is a unary operation, mean this is applied on a single variable. But and or, this is binary operation, so you need two values to apply and or and jar operation. So now I will give you example. Like suppose you have a value like this 1100. So if you will left shift it by 1, then simply what will be the result? This will be the result 11000. If you are shifting a, a number by 1, then that number is multiplied by 2, or you can simply put 10 there at the end. Okay, and if suppose this is uh, if you do this 2 times, then 20 will be there. Actually 1100 is equivalent to 12. This is 12 in decimal number. Okay, and this number is 48. Okay, so let's check it. Okay, suppose here I will show you, like print 12 modulo 2. Okay, now run it. You see 48. So if you are shifting by 1, then simply you are multiplying by 2, because I shifted 2 times, so that's why it's multiplied 2 into 2, 4, right? If you will multiply it only one time, then it will be 24. If you will multiply it 2 times, suppose 3 times, means you are simply multiplying 12 by 8, because 2 power 3 is 8. So this will be 96. Okay, so I hope now you understand about the left shift. Uh, Now I will discuss about the right shift. So similar to multiplication, if you will do a shifting, if you shift a number right shift, then what will happen? You are doing the division. You are dividing this number by 2. And if you are, okay, so I think this is the, let's see this. I am just by 1. So you see the result is 12. 6, because 12 is divided by 2. So we will get 6. So this operator is division, and other one is multiplication. Or simply what, suppose you have this number 48 and we want to left shift by 4, right shift by 4. So what you can do, you can just remove 4 last 4 bits from this one, and that will be your answer. Okay, so if we will do this, then what will be the answer? Answer will be 1 1 only. Okay, so you will get this number. Now I'm going to use some other value like 1 1 1. Okay, so this is, and I'm going to left shift this by 3. What we will get? After this we will get 1 1 0. Okay, so that was about right shift and left shift. With practice, I think everything will be clear. If you are not understanding what I am saying, don't worry. With the practice, everything will be clear. So just remain focused and try to understand what I am saying. So that was about left shift and right shift. Now I will tell you about AND operator. So what actually AND do? Suppose you have a single one bit as 1 and another bit as 0. So if you will perform the AND on that one, okay, before this, let's discuss again about the operator that we had discussed, AND. So what was AND? If X and Y. So that this condition is true only when both of them are true, right? So similarly here, if you are using AND operator and both the binary values is 1, only then the result will be 1. Otherwise, it will be 0. For all other cases, if suppose 1, 1 and 0, you will get 0. 0 and 0, you will get 0. 0 and 0 and 1, you will get 0. Okay. So, but one thing is mm, one thing you have to notice here is that this is the binary number, not decimal number, right? So this is actually one bit. Actually, the computer works in a only the computer system only understands 0 and 1. Okay, that I have that you will learn. So and this is called one bit. Okay, so if you will know about the representation of a number, then you will know about bit and bytes. So just know that this is one bit only. So on bitwise, this operation is performed. Like suppose you have two number 12 and 11, 12 and 14, suppose, and you want to perform the AND between these two numbers. So what actually will be done? 12 will be convert 1100 is binary number of 12, and For 14, the binary number is 1110. Okay, so if you will convert, so what will happen here? Okay, so 1100 and 123 and 0. So what will happen? Here both of them are 0, right? So first bitwise AND will be done for these two number. Okay, so 0 and 0, what will be the result? For 0 and 0, it will be 0, right? That's good. 0 and 1, again 0. 1 and 1, 1 and 1. So if you will do the AND operation of 12 and 14, you will get 12. So I will show you that also. So instead of this, I am just writing here print. Okay, and let's run it, and you can see the result 12. Okay, so I hope now you know about the AND or AND operator. Now let's learn about the OR operator. So similar to this one, for the OR operator, this is the OR operator. So with the OR operator, if both of them are 1, then this is 1. If any one of them is 1, then it is 1, otherwise it is 0. If both of them are 0 only, then it is 0. Okay, this is the OR, and this is the AND. So now let's take one more example. Like suppose you have a value like 101 and you have OR operator 001. So what will be the answer? If you can practice, please pause the video and do the practice and check your answer. Okay, so now I'm going to do it here for you. 001. So result will be 101. That's right. Okay, so the binary value of 101 is 5 and this is 1. If you will do the practice of how to convert from decimal to binary, uh, it would be, you would know how I write these values. Okay, so let's check that also. Now I'm going to use here 1 and I'm writing here 5 and I'm doing 1. Okay, OR operator, and I'm running it. So you can see I'm getting 5, right? Same answer. We also got here 5. Same values we were getting, right? So if you can check like this, okay, I will check some. Now I will talk about JOR. Okay, so with a JOR, it's like this. If both of them are same, then it is 0. If both of them are different, then it's 1, like this. Okay, so this is the JOR operation. So if both of them are same, then it is 0. If both of them are different, then it is 1. Okay, so I will give you one example here also. Like suppose the value is 1001 and 0110. Okay, so what will be the JOR here? Result will be 1 because both of them are different, and again different, so it is 1, and then again 1, then again 1. So the binary value for this is 9 and this is 6. So I'm going to do the operation, this operation, and I will show you the result. Okay, so 9 and 6. What is the result? Let's run it and check it. 15, right? You see, this is the 15. You can check it. Okay, if you will convert this number, you will get the 15. Or there is one more way you can see how to check binary value binary value in Python. Okay, you can simply type bin, then you will get that in binary. Okay, so I will show you this also. Like if I will write bin here, bracket, and again bracket close, so you will get the binary number. So this you see 41, right? This B is indicating that this is a binary number. This is just a notation. So I hope now you know about the operators. Thank you so much and see you soon. Bye.